welcome. In this video, we're going to create a cable tool of Project Titan. So in this first part, let's create the base of this tool. In Houdini, we of course want to work with some geometry. So let's use our geometry nodes to jump into a geometry network. And we're just going to simply start out with a line. This is just a representation of our inputs. We can of course later on change this. So we can grab a line, and we're just going to grab the properties. And we're going to here grab our handle. And we're going to rotate this so it actually sort of like falls on the grid here. Now, furthermore, we want to actually make this a bit longer. We can just say size 10. And for our cable tool, we also want to add multiple points on this line to actually be used in a simulation or other things. So we're going to use a resample node to add more points. And of course, this is something that you can tweak. So if I enable points, we have all these points, so we can always tweak this if you want more or less points based on what you would prefer later on. So this is my base line, base curve. And on that, I actually want to create multiple curves. So from this one curve, I want to create multiple curves. And the way I'm going to do that is actually by using the sweep node. So if I plug in the sweep node here, by default, we need to, for example, use the round tube. Then we can see that we have the round tube. And we could also, for example, here set it to actually columns. Then we actually have multiple curves around that. But in case you want some more, I would say, variation, we can also use the second input here for a custom shape. So let's create a custom shape, and starting with a cylinder. So we can create a cylinder. So if I plug the cylinder in over here and switch this to that input, we're now controlling this by the cylinder. So if I increase this or lower this, I can do this with the cylinder here. Now, what can be useful here is that we can actually sort of, I would say, distort the shape a bit. So we can do a, for example, noise pass. So what we could do is we could type in mountain, and this will give us the mountain, or this is a newer version of the mountain node. And you can see that this will add some small changes to the shape, as you can see. And in this node, we of course want to make some changes. So here we can see that we are controlling the points, the position of each point, and we are controlling the X, Y, and Z. So you can quickly, for example, turn this off on each individual axis here. And also currently, I'm not going to use the noising align the vector. I'm going to disable that. So you can see that you get this weird shape. And I only want my noising to be actually in the X and the Y axis. So I'm going to disable the Z axis here. So you can see that this is just a flat surface now in the Z axis. And maybe just tone down some of the noising here. We can just offset this. Let's go back here to this shape. And as you can see, we are now having sort of like a bit more random shape that we can make. Like we can do some quite random shapes with this. So we are not like having a perfect circle of cables, but we have like a bit more random cables going on. And of course, if you want more or less, we can always come back to the circle. Let's say we want, for example, 4 cables. We then have here just randomly 4 cables there. Now, something interesting here is we could also calculate, for example, the distance between each cable now. And we could save that in a value to use later on. This is not something you have to do, but could be interesting information to work with. So I'm going to use the connect points here. So connect adjacent points. We're going to set this to this mode over here, and we're going to increase the search radius. So as you can see, it's sort of like making connection between each point. From that, I want to do a convert lines. And this will automatically calculate the length of each line here. So I now have this information by default, so it will calculate this line. So if I would go to my attributes here, if I go to primitive, we now have the length of each line available. So with that information, I would like to get the minimum value of the length on each point. So we can simply do this by actually promoting the value. So by promoting the primitive to the points, so we're going to go from primitive to points, so the length here. So by promoting them from primitive to points, we can choose the promotion method. We can say that get automatically the minimum value that is connected to the points. So as you can see, each point here is connected by 3 lines or primitives. So by doing this promotion method, it will look at those 3 lines and it will get the smallest one. And then if we go back to our attribute spreadsheet, you can see that in the primitives they are gone. But in the points now, we actually have this available. And what we can also do now here is we can name this to, for example, the p-scale value. And let's use this in my output here. And if I now do, for example, another sweep node, and we set the sweeping here to the tube. And what if we set the radius to 0.5? We now have a situation where the cables should never intersect with each other. So if we need this value, we can get it later on in case we would need it. So we can always go back to our noising here, our mountain noise, and normally if we should play around with it, we should have a quite consistent result of having those tubes sort of like nicely fit into each other. So if I now increase more of them, they will actually nicely fit with each other. So this is like a simple way of doing this. It's just by getting all the connections. As you can see, we're just getting all these connections and then finding the shortest connection, and then we have that information. So now let's already do a little simulation setup here. So what we're going to do is, of course, we're going to use the Vellum. So let's type in Vellum, and we can see we have multiple Vellum solvers and things to do. So the first thing we need to do before using a simulation or the solver is to actually do a configuring of it. So we need to say what this type of data is. So what we can use in our case is actually the hair. So if I click on hair, we can, for example, just plug this in over here, and we can now use the hair settings. This could also work, but I personally also would like to actually use the string type here. So you can see that we have multiple types. So I'm actually going to switch to string. Either way, it will both work. If you would choose the hair or the string, they will both work. So now let's use our solver. So if we type in solver, we have then our actually Vellum solver. And if we actually hold the J key, we can quickly connect those dots. So now if I would actually bring in my timeline and press play, our simulation here will just fall. So we did not actually attach the points. So that's the next step here, is that we need to say that the beginning and the end of the points should not be moving. So we can do this by a group, so group range. And the range group actually has a feature to automatically here select the start and the end of a certain input. So now let's go to group type, set this to points. So now we are selecting all the points. We're going to say start 1 and end 1. And we're also going to say invert range. So now we have only these 2 points selected. By default, it's not going to look at the connectivity of the input or the lines here. So we're going to have to go to connectivity, and we're going to here have to enable this toggle, and we'll actually look individually on each line. So now you can see that each of these have now been correctly selected at the beginning and end. Now, furthermore, we want to probably give this a better name. Let's just call this pin group. So these are the pins. And in our Vellum simulation properties, we're going to scroll down to here the option to pin the animation. And we're going to use here the pin group that we just made. So there are some more settings we can do here, which I will use later. But for now, let's just focus on getting a very basic simulation. So if we now here press play again, we should have this result. So we have just the cables hanging. This is our first simple animation here with Vellum. Now we can try to quickly make this a bit more interesting by adding, for example, a random value on each cable. So as we here have a couple cables, let's do a random generator. So we can just type in random, and we will have an attribute randomizer here. So we can use this now to create a value on each line. So we're going to have to set this, of course, to primitives, because each line is a primitive. So you can see that they all have now a different color. And with that, we actually don't need a color. So we can just rename this to random. And we can lower this to just 1 dimension. So it's actually just going to return a value from 0 to 1 now. Now this random value, I'm going to promote this back to points. So we have this in the points information, because now it's set to primitive. So if I would go to my spreadsheet, we have this in the primitive stored. So I want to go here and again do the same thing as before. So we want to promote something from primitives to points, and this is the random value. So let's plug that in over here. And we want to use this random value now in our Vellum configuration. So we want to multiply the random value by, for example, the weight or the stretchness. So here, if we could play around, for example, with stretching, this will actually influence on how much sort of like it would hang down. So if I increase, for example, here this value and replay this, you will see that the cables are now very long. They're just like stretched more over time. So let's try and do, for example, here on the damping ratio, maybe we can just scale this by our attributes. So in this case, we called it the random value. And let's try to reset this. So what I notice is I still have a small issue here where I actually turned out to be having a lot of different cables that I actually had on one line, which I will talk about in a moment. So, but first, to maybe go back to some of the configuration, let's maybe play around here with this damping ratio. This just changes to 0.1 and maybe hit here resimulate. And you can see this is a quite interesting result already. So you can see that each line or cable has a quite different weight or stretchiness to it. That's sort of what we want to do with this random value. So we have like a little subtle randomization in there. So now maybe let's go back to my sweep node. And if I, for example, hold my middle mouse button, I can see that I actually have more primitives than I was expecting. So what is happening here is I actually did this calculation for the scaling in between, which caused to actually put out more primitives than I was expecting. So what I can quickly do this to, for example, solve is let's just use an attribute transfer. And what are we going to do is we're going to use this clean input and we're going to transfer our data, and we're just going to get the information here, or actually just the p-scale value, and actually convert it here on this cleaner shape. That probably gives us a decent result. Here in the transferring menu, we're going to say to only transfer the p-scale and plug that in over here. So now we actually have, if I hold my middle mouse, the 8 primitives I was expecting. That's more correctly. And we still have that scaling attribute since we are just transferring that over here. We can always here go back to the transferring threshold and so on, and maybe you can lower that a bit. But it should not influence that much. So if we go back to my simulation, of course the overlapping cables are gone now, but now we still have a proper clean output here. And that was it for this first video. This is the very base setup of this tool. In the next video, I'm going to add some more interesting effects and also then talk about later on how to bring this in game engine. Thank you for watching.